This is the solution video for section 7.2, problems 7 through 9. R of t is the rate at which water flows from a pipe in gallons per second at time t seconds. All right, so 7 says estimate the instantaneous rate of change. So instantaneous rate of change, remember, means derivative. So of r at 1 second. So I'm actually trying to find r prime of 1. Now, we can't find this exactly, right? We can't find the actual value. The best thing we can do is to estimate that value. All right, so what is the derivative or instantaneous rate of change? It's the slope. So we are trying to estimate the slope of this function. So how could we do that? Well, we have points. We have a point at 0, at 1, at 2, at 3, 4, 5, 6, and so on. So if we're trying to estimate the slope at 1, we can use the points from 0 to 1, points from 1 to 2, or the points from 0 to 2. So if you think about the graph here, if you have, here's a point at 0, 9, here's a point at 115, here's a point at 218, right? It would look something like that, right? So if you find the slope between 0 and 1, and the slope between 1 and 2, and you find the average, that's actually the slope from 0 to 2. So that's what I'm going to do. I'm going to find the slope from 0 to 2, so I'm going to take 18 minus 9 divided by 2 minus 0, so 9 divided by 2. So 9 halves is my estimate. All right. Now it says give the unit of measure. So what did I do? I took R values divided by T values. R is gallons per second and T is seconds. So this would be gallons per second divided by seconds, which is gallons per second squared. All right, so that's 8. Or sorry, that's 7. 8. Find the average rate of change of R. So average rate of change is just like the previous one. It's actually the slope, but specifically the slope between 2 and 6. So I'm going to find the slope. So this is the slope of the tangent, or sorry, the slope of the secant line. All right, so from 2 to 6. So I'm going to go 56 minus 18 over 6 minus 2. All right, so 56 minus 18 is 38 over 4. Right? And so, let's see. All right, 38, 4, those are both divisible by 2. So 38 divided by 2 is 19 halves. All right, and so give the unit measure. Once again, I took a y value divided by an x value or an r divided by t, so I get gallons per second squared. All right, lastly, number 9. All right, estimate the algebraic area under R from 0 to 6 using a midpoint Riemann sum with 3 equal subintervals. So if I'm using 3 subintervals, right, from 0 to 6, that means 0 to 2, 2 to 4, 4 to 6. All right, so 0 to 2, how wide is it? It's 2 units wide times the middle point, so 15. Plus the next one, 2 to 4. How wide is that? That is 2 wide times the middle point, 26. Plus 4 to 6 is 2 wide times the middle point, which is 40. All right, so 2 times 15 plus 2 times 26, 52, plus 2 times 40, 80. All right, so I get 30 plus 52, 82, plus 80 is 162. What? Units of measure. Well, remember, I found an area, so I was taking an R value multiplied by a T value. So gallons per second times what? Well, times seconds. So this is actually an amount of gallons, right? So 162 gallons is our estimate of the algebraic area under the curve.